Hello, I'm Owen O'Malley. I'm a co-founder of Hortonworks, and I'm here to talk today about keeping your enterprise data secure. So I've been working on Hadoop a long time. My first patch went in before it was even called Hadoop, and I was the architect for security, and although most recently I've been working on Hive and Orc. Okay. So, sorry, the display went different. So the important questions with security are, what are the threats? And that's actually the most important piece. Often you get presentations about the specific security features, and I'll talk about those, but actually the most important piece to think about is what threats are you worried about? You also need to minimize the attack surfaces. So sometimes you need to make decisions based on how do you cut things down and keep them from being available to attackers. And you need to control who has access and what data does your corporation have. So the first piece is that you need to turn on HDFS permissions. Actually, by default, they're on now. Originally, they weren't, and that led to some pretty serious problems when it was being used at a university, for example, and one of the students finished their project, and all of a sudden, they decided to delete their home directory, while they deleted everyone else's too. The other thing is that mistakes happen. So you always need to have trash enabled so that you can undo it. And you need to have the audit log enabled. If hackers break into your company's systems, and eventually they will, then you need to know what they looked at, basically. The last piece is that you absolutely need to avoid group accounts. I've talked to some companies, and when you are talking about their security infrastructure, they have everyone log in and then use group accounts for everything. That leads to problems because now your audit log is in terms of those group accounts, and that means that you have almost no information about who did something. The other piece you need to absolutely make sure to have set up is to have the Linux container executor. It's a small setuid executable, so we created that so that we could minimize how much of the code had to run as root. And it provides isolation between users, and it also gives you local file permission. That does a lot of things, but in particular it means that users can't see each other's files, and so that's absolutely mandatory. Now, one of the pieces that's really exciting is that Yarn is actually starting to support Docker. You don't actually want to turn that on yet, but we're getting there. And when you do, it'll let you get out of a whole lot of arguments about which version of Python should be installed and which version of each of the tools in the environment is set up. Okay, so when I said I was the architect for adding security, that really meant integrating Kerberos. And when we added Kerberos, that decision was based on the fact that Kerberos is the industry standard interface for defining authorization. So it really gave us very fine-grained control over who was logged in. And however, Kerberos wouldn't scale out to the thousands of machines that most Hadoop clusters run at. So we created delegation tokens. Delegation tokens are tokens that are put along with your job and give you rights for each of the services that you have access to. They're typically good for 1 day and renewable up to 7. So if your job lasts longer than that, you're going to need to configure your delegation tokens for longer. but that gives you very fine-grained control over what your job has credentials for. In particular, we didn't add the Kerberos capability, or we didn't add the Kerberos credentials into the Yarn jobs, precisely because we didn't want the user submitting applications that had their actual credentials in it. Okay, so the next piece that you need to think about is that the user group mapping. So HDFS, of course, defines things in terms of user group other, like most operating systems. We've also added ACLS to give you additional flexibility. But in most cases, actually, you don't need it because there's a user group mapping that lets you define what gets mapped to what, which roles each user has. And so even if your organization hasn't defined those as part of the LDAP, then you can still get it for Hadoop. You do need group directories, and you need to set quotas up for those. And you need to minimize the number of user and global spaces. Oh, come on. There we go. Okay, so now, when you turn on security, mostly it's a headache for your sysadmin people, but you do actually need to change your code for if you're a server too. And the primary thing is that each service needs a key tab, which is basically just a Kerberos password for a service. And when you start your program up, you need to do login from key tab. And one of the critical points that we hit very late in the process is when you're testing, make sure you test for longer than 24 hours. Okay, so when you have a remote service set up, then you need to set up who can access the service. And so Apache Ranger, which is a project that started actually as a commercial product that Hortonworks bought, and then we contributed it back to the Apache Foundation. And so it makes a lot of the security stuff much, much easier, and we'll go through more of the details later. You also need a firewall around your cluster, and you never should let your users log into masters. So this is the typical diagram for what it looks like. So users either log into SSH gateway and then submit commands, or there's a project called Apache Knox where you can get a REST interface to access your Hadoop clusters. So either way works, and we have customers that use both. But always put that firewall around your cluster. Now, one of the issues with security is that you need to worry about who can watch the traffic. Now, depending on your network configuration, users can see it, but fortunately only the super user. And so we need wire encryption. And there's actually 3 different pieces. There's RPC encryption, data transfer, and the MapReduce shuffle. They're all relatively expensive, so you only want to enable them where you need them. And because it's unlikely that the attackers will have root access inside your data center, they're usually not recommended. Now, in some cases, corporations have requirements that makes them enable all of this. Actually, I talked to one financial customer, and they were like, oh, we turned on all the encryption all the time. That's not actually recommended. What you want to do is think about what's required and make sure that only the pieces you need are enabled. Now, that said, on the other hand, once you're going to the internet, then you absolutely need to make sure that the encryption's turned on, because across, even inside your corporation, you need to make sure that you're using HTTPS for all of the communication. So you'll need to set up SSL certificates and create a master certificate to sign all of those certificates. Otherwise, your data will be going in the clear, and that's going to open you up to lots of problems. Come on, go. There we go. Okay. Now, fortunately, most of your big data clusters are actually in the data center. And so most companies don't actually worry about physical access. It's a very rare attack vector, actually. If they can get to the physical box, though, it's basically hopeless. There have been experiments that showed that as long as you can get the box cold enough, when you power it down, the memory is still readable. And even so, you can take it out of the computer it's in, put it in another computer, read the memory chips, and you can still get data off of them. So you don't try to protect against that. You just try to protect against the case where they don't have physical access. Now, for most corporate data centers, when computers leave, they've had their hard drives destroyed. Most corporations I've seen grind up the hard drives so they don't leave anything bigger than sand left when the disk leaves the system. Otherwise, you probably should turn on the raw file system encryption. Okay, now if the person manages to get Hadoop admin access, but not root, then you're actually in a slightly different case. Then you actually want to turn on HDFS encryption. HDFS encryption lets you encrypt particular areas of your HDFS namespace and make sure all the files inside of that are encrypted with a master key. Now, this does two things. The first thing is that you can back up the data without having access to the key. And you can make sure that it never hits the disk unencrypted. So it really does both pieces for you. And it makes sure that each file has a unique key and that the client actually does the decryption of the data. So, like I said, each directory that you've defined as an encryption zone actually gets a unique key. The user never sees the master key. The master key stays on the KMS, which is a key management server. The file gets a unique subkey, and HDFS stores that encrypted subkey and gives it out to the client when they ask to decrypt a particular file. There is a noticeable impact, performance impact, but we're making that better as we speak. Okay, come on, go. Okay, so we said that there's a key management server. Now, Ranger provides one, but we wanted to allow third-party plugins to work. And so we created an interface that lets third-party plug in a key management server and go through. It provides named keys, key versions, and key rolling. The key rolling is so that you can have your data encrypted using a key that's changed daily and continually create new keys. Now, one of the use cases for that is some companies need to delete the personal identifiable information, PII, after 90 days. One way to do that is by creating a new key each day, encrypting that day's data with today's key, and then deleting it after the 90 days. Okay. So what does this look like? Here's what it looks like with Ranger as the KMS. So the HDFS client talks to the name node, gets the encrypted key, gives the encrypted key to Ranger. Now, Ranger actually has an option to talk to a hardware security module, and the master key is actually stored there. And then Ranger gives back the decrypted file-specific key to the client, and the client runs from there. So you can see that the master key never leaves the HSM, and the client still gets fast access. Now, of course, when we were designing this, one of the options that we discussed first was all the decryption happens on the server. That there was no way to make that perform. Hadoop is basically an amazing tool for distributed compute, but the problem is that it can be a denial of service tool as well. Sorry. Okay, so what do we do about tables? Although Hadoop was originally set up to deal with schema-less data, in fact, the vast majority of the data that we get is in tables. So sometimes we want to protect sensitive columns like personal information. We want to restrict rows, perhaps based on the different regions, or only enable doctors to see their own patients' information. But in whichever case, we want to restrict who can see what at a finer grain than at the file level. So because we need it at a finer grain level, HDFS permissions don't work, and we need to use Hive Server 2. So traditionally, Hive was set up like this with storage-based authorization. The storage-based authorization means that it uses the HDFS permissions to see who's allowed to do what to the database. That works well for Spark and Pig if they want to access the same data, but it means that you can only be as granular as the HDFS files. So instead, we added Hive Server 2. It's called Hive Server 2 because there was a Hive Server 1 that has disappeared. So the user connects with the JDBC to the Hive Server 2, and Hive Server 2 does the authorization checks and then runs everything downstream of that. So with Hive Server 2, then you configure the Ranger security policies, or you can use the Hive SQL Standard Auth, and you restrict the permissions on HDFS so only the Hive user has access. Okay, so what does Ranger let you do that's finer grain? Ranger has this access-based, attribute-based access control, and that really lets you decide who has access based on who's doing it, what the environment is, what the time is, where they're doing it from, and you can make policies based on all of that. That gives you a lot of control to micromanage exactly who can see what and what they're allowed to see. So that's how you, for example, go in and create policies that say, okay, this doctor can only see their records, or someone in Europe can only see the European records, but the people in the United States can't see any of the European records. And you could do all this with specific roles and groups outside of Ranger, but it would create more and more of these groups as you created a group for each different combination that you were worried about. And some of them would be really hard, like depending on what time of day it is, you don't want to change which groups a user is in, but you can change their attribute-based access control. All right, so if someone doesn't have access to all of the data, but they do have access to some of the data, then you need to give them limited access. Now, this is a very hard problem. Data anonymization has been one of the areas of research that's been very challenging for the people to get right. I don't know if any of you have heard of AOL at one point sent out some of their search logs for researchers. They anonymized it, stripped all the user information off, but they left a token there saying which user was so you could do correlation across queries. Well, it turns out that that wasn't actually very anonymized because while you couldn't tell the vast majority of the users, people search for their own names often enough that you could figure out, okay, if this person is searching for someone random and they're doing it more than once, that's probably that person. And because then you could tie it to what else they were searching for. You could tell where they lived or what medical conditions they had. So it actually became a great big problem. So take this stuff very seriously and think about what's masked and what kind of information you're giving out. So Ranger has a couple of different masking policies. It's got redaction, where you change most of the characters into X's and the numbers into 9s, but you can still get a general idea. That doesn't give you very much information, but it at least lets you see what it looks like. Hashing, on the other hand, gives you a consistent hash of the value so that you could do joins against it. So for example, if you've got the hash of someone's credit card, then you can join against other tables that also have that same hash. You also have tokenization, where it's replaced with an ID. Now, with all of these, you have to be very careful. For example, New York City had the taxi data published, which was a great data set, and actually is a data set I've used a fair amount. But they did hashing to redact the driver ID. Well, unfortunately, because the driver IDs were assigned from 1 sequentially and they were public, that meant that you could figure out the hash of each driver and figure out who had done which routes. So again, be careful with this. And Ranger does allow user-defined tokenization. One of the pieces that I'm really excited about is that for users that need masking and encryption, we're adding into the ORC file format encryption, where you actually use the Ranger KMS to get encryption inside the file format. So you just encrypt the columns that you want. And it includes static masking of the data. So you get to define when you write it how the data is masked. All right, now one of the issues that often comes up is that, okay, Hive Server 2 works great for Hive, but now we want to access it from Spark or Pig or one of the other file formats or execution engines, and that doesn't work. So what we've done is, as part of creating LAP, LAP stands for Live Long and Process, which is a caching layer for Hive, and it actually executes the first scan of the data and the processing of the data in the standing servers. And the main goal for LAP was really to create sub-second responses from Hive, and in fact, it's worked really well for that, and we've gotten queries across tables with 6 billion rows coming back in less than a second. But as a side result of all this, we actually can hook Spark up to LAP and create an LAP context. And what that does is now you get the same Ranger policies applied through your Spark data. So you can read the data from your Hive tables, filtered by the Ranger policies, and process it in Spark. All right, so that works great for your for protecting the data. But now, how do you figure out what data you have and how are you going to protect it? And as part of what happens with clusters and big data in enterprises is that it's continually growing and getting bigger, and you get more and more of it. And so what we've found is that a lot of companies have problems keeping track of all of it and where it is and how it's being protected. So we created Apache Atlas, and it really tracks both the data and where it's coming from. It has extensible data modeling and integrates with other metadata systems so that you can propagate the information to your other tools. Now, part of what it tracks is it tracks which flows create the data and which flows use the data, and you can actually query it. And actually, this kind of analysis is really, really handy, especially in the case of break-ins, but even more operationally, It's really useful for seeing which flows are producing tables that are unnecessary. One of my customers went through and figured out that they were generating a bunch of tables that no one was reading, just because they always had. Of course, it also helps you figure out other cases, like there were some work tables that were being updated by multiple flows, and they weren't locked against each other. So this is a really handy piece of. Oh, come on. There you go. Another feature is that it can classify data. So you can tag your data saying this is PII or financial data, and then Ranger can use those tags to control the policies. You can also search through the data. You can say, okay, I want to see all of the Hive tables where it's PII or has a name in the pattern, and then tag it appropriately. And finally, you can actually enter more advanced queries. Oh, come on. Sorry, this clicker is not my friend. So the key takeaways are that to think about security in terms of threats, think holistically about security, consider encryption and be particularly careful with data masking, and finally, create a data catalog with Atlas and identify and classify your data. Thank you very much. Oh.
Thank you very much, Owen. Security is one of the areas that we neglect the most. Yes, I can over the back of the stage. Yeah, I did. A question for you. So how do you see security, well, not Hive or more abstract or more general, how do you see security implemented in big data platforms? I mean, you are in Madrid or in Spain. I think you are free to maybe give us a little bit of edge there, your opinion. So
it's really part of the frustration of the big data platform is that there are a lot of different pieces. And so, for example, Spark has been very slow about adopting anything that except for file-based. That's part of why you need to plug something in like LAP that's doing the security check on the bottom, and then providing the data so that it happens automatically and the user can't work around it.
Do you think the awareness of this is growing?
Absolutely. Almost all the customers end up with security turned on. They usually start without security and then quickly turn it on. And so it's absolutely growing. And especially as more execution engines start showing up, then the data becomes more critical. And certainly the new regulations that you've got in Europe are making a lot of big changes, actually. And actually, that's one of the pieces that I didn't have time for. But Hive has actually added ACID properties recently so that you can update the data. And that is incredibly important when you start to talk about wanting to delete people's records, which is part of the requirement for your European restrictions. And so, absolutely. Actually, one of the companies I work with has a project to implement forgetting particular people's records, and they called it Project Machete, which I thought was appropriate.
But that must be extremely difficult, right? To try to find all these.
It's extremely difficult. And actually, that piece is, they're still working out the details of how to do it. But part of the challenge is that they have to figure out what to do with the aggregates when someone gets deleted, right? Yes. If they have it summed up to the postal code, then do they update the postal code or do they leave it alone? Because both directions have challenges, right? Because if you're changing historic data, then you've made a decision to change things retroactively.
Yes.
but on the other hand, you have to forget them, and you can't let that delta identify them.
Absolutely. Yeah, big challenge there. Okay, so I would like you to thank Owen, co-founder of Hortonworks, for having been so nice as to come here today to Madrid. Thank you very much, Owen.